Hello everyone, welcome to Coders Camp. We are at 12th day of December LeetCode challenge, and the problem we are going to cover today in this video is partition equal subset sum. So the input given here is a non-empty integer array nums, and we have to return true if we can partition the array into two subsets such that the sum of the elements in both subsets are equal. So let's understand this with an example. So here is our given example in the problem statement, and we have to divide these array into two subsets such that both the subsets are having equal sum. So here let's start with the elements given in the array. So now each element must be in either of the subsets, which will be either in subset 1 or in subset 2. They can be in both the subsets. So let's start by having 1, 5, 11 and 5. So 11 is the higher value out of all these four. So let's put 11 in the second subset and start having the subset by 1, 5 and 5. So the sum of subset 1 is 11 and the sum of subset 2 is also 11. Now, so we can form two subsets with the elements whose sum are equal. In that case, we are going to return true. So how are we going to approach this problem? So this problem is a variant of 0-1 knapsack problem and subset sum problem. So before getting into the logic of these things, let's understand what are all the observations we can make from this problem. So the first thing is we have to divide the array into only two equal subsets. If the subsets sum or have to be equal, then in that case, each subset will hold the sum of sum by array. So if suppose said to be S is the sum of array, then each subset will be having, subset 1 will be having the sum of array by 2, and subset 2 will also have sum of array by 2 as their sum, because we have to divide them into a equal subset. So clearly we know what is the target sum we have to look for to form a subset. So the second thing we can say is the sum of array must always be a even number, because it is clearly said we have to partition the subset into equal sum. If we have to divide them into equal sum, then the sum of array must always be even. If it is odd, we can't divide them into a 0.5 or something decimal value. We should always have an integer value. So the third thing is, if it is odd, we can clearly return false. If the sum of the array is odd, we can clearly return false. So if the sum of the array is even, there are two choices. This can be true or false. How? Consider two subsets. The first array is having 1, 4, 5, and the second array is having 1, 6, 3. So in this case, both this array are having the sum 10, which is even. So we cannot come to a conclusion that we can divide them into two, because in first case we can divide 1, 4 as one subset and 5 as other subset, which forms equal sum, and we have divided that into equal subset, so the result is equal to true. In the second case, if we try to divide the values, you can't divide them equally, because 6 is a higher number. Even if by ignoring 6, if you add the other values in the array, you can't make it to 6. So you can't divide this array into two equal subsets, then the result is going to be false. So these are the observations we can make. And other important observation we could do is, so if we are picking the numbers to put in subset 1 and subset 2, clearly if you put a number in subset 1, then you can't put the number in subset 2. So if there are set of values in subset 1, then the remaining values in the array are obviously going to be in subset 2. So this is where the concept of 0-1 knapsack comes, because for each value you have two choices. You can either put that in subset 1 or subset 2. So all the cases we have covered was to define the base cases of the problem, but here comes the important logic. So as I said, this problem has the logic of 0-1 knapsack, because each element in the array would have two choices, either to go in a subset 1 and subset 2. So clearly, if we put a set of numbers in subset 1, then the rest of the numbers in the array would go to subset 2. So if we decide our subset 1 is going to have only 11, then obviously the rest of the elements in the array would go to subset 2. because we have to divide them into only two equal subsets. So once we put the element in one subset or decide the elements in one subset, then the rest of the elements are going to be in the other subset. So now we know the target to each subset, which is nothing but total sum of the array by 2. So we clearly come to a problem that says you have to form a subset whose sum is equal to sum by 2. So the problem now shortened to form a subset whose sum is equal to target, or whose sum is equal to sum of array by 2. And that's it. If you could able to create a subset from the given array whose sum is equal to target, then you can clearly return true, because once you find one subset whose sum is equal to target, then obviously rest of the elements would form another subset whose sum is again equal to target. In that case, this is going to return true, and that's it. And the sum is actually over. So you have to have the same algorithm that goes with subset sum, that just find a subset whose sum is equal to overall sum of the array by 2, and if it could able to find a subset whose sum is equal to target, then we are going to return true. So hope you understand how we solve subset sum and knapsack problem. The same code can be used for this problem as well. So we are going to see the recursive code today, and you can go for any tabular method of dynamic programming, and any method of knapsack problem and subset sum will work for this problem as well. So before getting into the problem, this is going to work in big O of n cross w time complexity. So here n is the number of elements in the given array, and w is nothing but weight in knapsack problem, which is also here is the target sum. So hope you're understanding the overall logic of this problem. Let's get into the code now. So as I said, we clearly gonna have a method that calculates the subset sum whose sum is equal to target, which is gonna finally return a Boolean value. So before getting into the actual logic of subset sum, let's finish our main method with all the base cases we have seen. So first, let us calculate the sum of the array. And as I said, we are going to check if the sum is odd, then we are going to return false. If not, we are going to call the subset sum method to check if it can form a subset whose sum is equal to sum by 2. So yes, now we have our sum calculated. Let us declare our Boolean DP array and call this function. So here the sum is actually sum by 2, which is nothing but a target. And let's start from the index 0. And so now inside our subset sum method, we are again going to do a bottom up approach, which is top down approach, which is nothing but we are going to have a target sum, and we are going to subtract each value from starting from the index 0 till the last element in the array from the nums array, and we are going to check if our sum reaches 0 at any point. If it reaches 0 at any point, means there are set of elements that has been subtracted from the target which made it to 0, which means we got the sum or few elements that satisfied the subset sum. So now we are going to check if at any point our sum reached 0, then we found our subset, which means we are going to return true. This is nothing but the exact code of subset sum problem. So if you're already familiar with it, you can skip this part. And if sum is less than 0, or our index has reached the last element of the array, at both this point we did not find, or none of the elements set or subset that satisfied the target sum, which means we are going to return false. And we are actually using this DP array for memoization. So every time we are going to calculate the value and store it in our DP array. So we are going to check if the DP array has been already filled. By default, the boolean will be having null value. So if it is not is equal to null, which means we have already filled or calculated the value for that particular sum. So in that case, we are going to return the calculated and saved value. So yes, that's it. All base conditions are done. Now we are simply going to calculate the value and save it in our memoization DP array. So we are going to call the same subset sum recursively. So every time we are going to call with the same nums array by negating or subtracting the sum of the element in the current index. And after subtracting, will be our algorithm will be checking with the next element in the array. So our index will be added by 1. If not, we have two choices. As I said, for each number at each index, we'd either put that into a subset or we ignore that element and go to the next element. So for every element, we'll be taking these decisions. So this is why it is kind of a 0-1 knapsack problem. So here we took the element for consideration. Otherwise, we'd be calling the same recursive method without considering that particular number for that subset. So we won't be subtracting that element. We simply ignore, and with the same sum, we proceed for the next element. So finally, our DP array will be filled with true or false, whether that particular subset satisfies the sum or not. And finally, we'll be having our answer at the DP of sum array. So at the sum, if it is true, which means for that particular sum, the array had set of elements that has been subtracted and made it to 0. So finally, we are going to return DP of sum, and that is what the output says. So that's it. Let's give it a try. So yes, let's submit. Yes, the solution has been accepted and it runs in 1 millisecond and 100% faster than other solutions. Thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.